Now this is a very interesting topic of number 3, that is fluctuating stresses. Now we have seen so many stresses. Now fluctuating stress we are going to understand in this video. Now what is fluctuating stress? Okay, when the components are subjected to forces which are not static but vary in magnitude. Okay, just see this line, but vary in magnitude with respect to time. The stresses induced due to such forces are called fluctuating stresses. We can consider a simple example for this. That consider an example of a seat of a passenger car. Okay, based on the road profile, the seat is subjected to stresses which vary in magnitude and direction with respect to time. Okay, the load may or may not be cyclic in nature. So the stress induced due to this cyclic loading can be considered as a fluctuating stresses. Okay, when the stress are not in a constant line, that is, it may vary. So magnitude is with respect to time. At that time, fluctuating stresses are considered. Means that stresses are known as the fluctuating stress. So 80% of the failure is being observed that it is just because of this fatigue failure, which are results from the fluctuating stress. We are going to understand fatigue failure also in the next slide, but first we are going to understand the fluctuating stress. Okay, due to this fluctuating stresses, fatigue failure occurs. That means fluctuating stress is the major cause which generate the fatigue stresses, and due to that the failure occurs. That's why the design analysis, that is simple model for stress time relationships, are used. The most popular model of stress time relationship is the sine curve. Sine curve is mostly used to understand this thing. So to understand this thing, most popular models, or you can say the load cases which can be considered under fluctuating stresses. There are three mathematical models, that is fluctuating, or you can say the alternating stress, repeated stress, and the reverse stresses. So let's see with the fluctuating stress. Now as we have seen that stress time relationship for these models are shown below. So the fluctuating, or the you can say the alternating stress, varies in sinusoidal manner with respect to time. It has some mean value as well as amplitude value. So it fluctuates between two maximum and minimum stresses, between two limits actually. It is maximum and minimum stresses. The stress can be tensile or compressive, or partly tensile or partly compressive. Any stress we can say. Let's see the graph for it. Okay, just see here. This can be considered as a tensile, and this can be considered as compressive, or tensile and compressive both are different we can consider here. So this is the maximum stress. See here, from timeline till this peak point, the maximum value is there, and from timeline to this is the minimum value, and this is the amplitude for this stress, for this sine stroke. Okay, this is a graph for stress to time. Okay, this is also sigma a, and this is also sigma a. We can consider any sigma a value. So this is how you can draw a graph. In this, the maximum, that is the mean stress, can be taken as sigma max plus sigma mean divided by 2, and the amplitude stress, that is sigma a, can be taken as sigma max minus sigma mean divided by. Now the next, that is the repeated stress. The stress which is repeated. Okay, the repeated varies in a sinusoidal manner with respect to time, but the variation is from 0 to some maximum value. Here we have seen in fluctuating stress, it is somewhat in middle part. Okay, and in repeated stress from 0 to maximum. Let's see the graph first. So the minimum stress is 0 here. Okay, this you can see here, the minimum stress is 0 here. Clear? In this case, and therefore amplitude stress and mean stress are equal. That means that sigma m and sigma a is equal. I have given the formula also in the next slide for this. So here sigma m is equal to 0. which I have already told you that for fluctuating stress, sigma m is equal to what? Sigma max plus sigma mean divided by 2. But here sigma m is 0 just because it is starting from the 0 value. Now the reverse stress. Now reverse stress varies in sinusoidal manner with respect to time, but it has 0 mean stress. Okay, here also mean stress is 0. In this case, half portion of the cycle consists of a tensile stress and remaining half of compressive stress. There is complete reversal from tension to compression between these two halves, and therefore mean stress is 0. Okay, so here half portion of the cycle consists of tensile stress and remaining half of compressive stress. Half is tensile, half is compressive. So this is how it can be shown that sigma m is equal to 0 and sigma a is the amplitude stress, and it is started in this. Now sigma max and sigma mean are the maximum and the minimum stress, while sigma a and sigma are the mean and the amplitude stress. Let's see the formula for it. In analysis of fluctuating stresses, tensile stress is considered as positive and compressive stress as negative stress. Okay, tensile is considered as positive and compressive as negative. So it can be observed that repeated stress and reverse stress are special case with fluctuating stress where sigma mean is equal to 0. So for repeated stress, we can say that the value of sigma m is equal to sigma a is equal to sigma max by 2. And for fluctuating stress, we take this formula. Okay, and for reverse stress, sigma m is equal to 0, and sigma a is same, just which we have shown. Okay, so this is how the fluctuating stress is there. Now in the next video, we are going to learn about the fatigue. Thank you.